Now let's look at some other problems that will use these divisibility rules to help solve them. So in this problem, I've given us a large number here. This is 2,143,890 something. We need to figure out what number should go where X is. And we can use any of the digits. So the digits are the buttons on your calculator. So you can use anything 0 through 9. We've got to figure out what we should put there. For instance, if we put, let's say, the number 3 there. If X was 3, that would be the number 2,143,893. So just replacing that ones place, the units place where that X is with any of our digits 0 through 9. Well, I'm not going to sit here and guess and check. I could do that, but it might take a while. So I'm going to use the divisibility rules here. So I know the rule for 5 says that a number has to end in 0 or 5 to be divisible by 5. So that means that X could be 0 or 5. Those are the two possibilities. Anything else, that number is not going to be divisible by 5. Doesn't matter what comes before it. That 0 or 1's place, which is where the X is at, has to be 0 or 5. Kind of similar is the rule down here for 4. So let me just skip down here and look at this one for 4. The rule for 4 says we look at the 10s and 1s placed together. Don't add them, but we look at together. For instance, that number could be 50, 51, 52, 53. It could be 5 with any of those single digits. The single digits are 0 through 9. You can look at your calculator. It's the buttons on your calculator or your phone if you're dialing a number. Just those buttons, those are the single digits. Now, 50 is not divisible by 4. 50 divided by 4 doesn't end in a whole number. We have a remainder. So this one doesn't work. 51 divided by 4 also doesn't work. But if I do 52 divided by 4, that does work. That comes out that 52 is divisible by 4. There's no remainder. So that means that X could be 2, because remember, we're finding this spot right here. And then thinking about what other numbers on this list would divide by 4 evenly. The only other one is 56. So that means X could be 6. The rest of these, if we try to divide by 4, we're going to have a remainder, or in our calculator that will look like a decimal. So these are my two options that I have right here. Now the one for 3 is going to work slightly different because the rule's different. The rule for 3, my divisibility rule that we went over in the last video, says that we have to add them all up, right? We add up all the digits. So I could start with what I have right here. So I've got 2 plus 4 plus 5. I don't know what X is, so I'm not going to add it yet. I'll do it in just a second. So I'm going to add up all the digits that I already have right here. So that adds up to 29. Remember, I'm only adding on this one because the rule for 3 says you add up all the digits. That's the rule for 3 and 9. So X, I would have to add to 29. All these other numbers are 29. The sum of them is 29. No matter what X is, I start with the 29. If X was 0, that would be 29 plus 0. Then I have 29 plus 1. I could have 29 plus 2. Plus 3, kind of similar to down below. This time it's just adding, since the rule for 3 is a sum. So those are my possible digits, right? 0 through 9. Well, 29 plus 0 is 29. That 3 doesn't divide into 29 evenly. 29 plus 1 is 30. Yep, 30 divided by 3, that divides nicely. 29 plus 2 is 32. 31. 29 plus 3 is 32. That one doesn't work. This next one is going to work, right? 33 divided by 3 is 11. It comes out to an even. It divides evenly. Then I'm going to get a few that are not going to work. And then when I get here to a sum of 36, it works again. And these guys aren't going to work either. So I've got 3 times it works. It works when I add the number 1, 4, or 7. So X could be 1, 4, or 7. one more question using these divisibility rules. This is still a little bit different from what we were looking at before. Still going back to those divisibility rules. So we want to know, why is the following not a valid test? So this doesn't work. I'm admitting that doesn't work. A number is divisible by 8 if it's divisible by 4 and 2. So sometimes this works. So like 16 works for 4, works for 2. Oops, and then also will work for 8. So sometimes it does work. But if there's just one time it doesn't, it can't be the rule, because the rule has to always work. So if I can find one number that is divisible by 4 and 2 and isn't by 8. So for instance, 12, right? 12 I can divide by 4 and I can divide by 2. But if I try to divide it by 8, that gives me a remainder, so it doesn't work. So this is a counter example. It said support my answer with an example. I did that right there. This is why the rule doesn't work. It works sometimes, but if I can find one example where it doesn't work. There are other examples as well, like you could use the number 20, for instance. There are lots of examples, in fact, they're infinity, but I just had to find one example where this rule stated up here, a number is divisible by 8 if it's divisible by 4 and 2, one time that does not work.